Hi, everyone. Welcome back to our panel discussion. We've had a number of questions come in, and we certainly want to get to those questions today. So for Alex, we had a question come in. It says the attendee really wanted to clarify a little bit. It goes back to your hexane extractor, the size. Specifically, they wanted to know about your pilot extractor, about the size of the hexane extractor in tons per hour for soybeans.
Yep. No, thank you for the question. Yep. It's a great question. So we have several extractors in the facility, from small to larger. The one that we use for custom processing for more to simulate continuous production. On a soybean basis, we are able to roughly 3 to 400 pounds an hour, so 150 to 200 kilograms per hour of full fat flakes feeding into the extractor.
All right. Thank you very much. I'm going to move on to our next panelist and try to run through so everyone gets a chance to participate here. Kerri-Ann, we had a question come in, and it says, do foods need to have a certain fat content to measure the oxidative stability?
For foods that don't have a lot of fat content, we have to be able to extract it. And that's done with what's called a cold extraction, where the material is ground up and an extraction process is done with petroleum ether. For the analysis itself, the average sample size is about 5 grams of fats and oils. I would say we could probably push it to 3 to 5 grams, but we have to be able to extract at least that much for the measurement.
Okay, great. Thank you. There was one follow-up question about that, and I think you may have answered it, about, is there any sample preparation needed for food products other than pure oils?
Right, yeah, it's just the cold extraction process that I just mentioned. Okay. That can be a little bit involved, but it's possible to do that. And we have information on those types of analyses.
Yep, great. All right, I'm going to move on and spread the love here about questions. Matthew, we had a question come in for you. It says, can you talk about the accuracy of the chlorophyll and carotene methods when you're measuring color?
Yes, we can measure those parameters. I couldn't tell you off the top of my head, I'm afraid. No surprise. That wasn't the main topic of my conversation.
Yeah.
But if you were to contact me, I'd be delighted to give you to provide the person with a detailed explanation. So just contact.
Yeah. Okay, Amy. Yeah. I think, Amy, if we can refer that question on to Matthew, and he can reply directly to the attendee, that will be a great thing.
Just measure those parameters.
Great. All right. Moving on down our list of panelists, Ernesto, we had a question come in. It says, what is the utility cost per kilogram of oil processed when using the new short path stripping technology?
That is a great question. Of course, there is a lot of ifs and depends on this. For example, let's take palm oil that is being physically refined by the conventional method of having to strip off literally the free fatty acids through the deodorizer. So the savings in just the amount of steam and energy in having to generate all that energy, we estimate about 50% savings in cost. So it's very rough. Don't hold me to that. Again, it depends on the quality, depends on many things. But in general, we estimate that the savings and energy costs, for example, are about 50%. Now, moving on, comparing to molecular distillation, where this technology, this artisan technology, is able to compete very efficiently, just keep in mind that the short path stripper from artisan has no moving parts, and still is able to produce a molecular distillation, a short path distillation effect think of the molecular distillation units, the conventional ones, where you have an internal wiping system that is moved mechanically under very high vacuum with very, fairly expensive sealing system and motors and electrical, consumption there. So there alone, you can see where the savings will come from. This short path stripper from Artisan having no moving parts inside and being able to do this multi-stage internal distillation system and having the short path effect, sometimes more than 50% savings in energy. And, I can go on and on the advantages with molecular distillation. You have the disadvantage of having limited size capabilities. With this Artisan system, you can make them as big as you need to, as big as a conventional deodorizer, whereas you cannot do that with a molecular distillation system. So, but if you have any more questions, we have only a short amount of time available to us, obviously, but please feel free to write and ask questions.
Okay, great. I'm going to save a few questions for you. We have a number of, let me just see. We have a number of questions for you, but I'm going to move on so we can kind of spread this among our panelists and keep the discussion going.
I'll be very happy to email or to answer questions to the.
Yep. So we have time. We have time. I'm just trying to rotate through each of the panelists with different questions to keep everyone engaged. For Christopher, we had some questions. It says, what is the typical measurement error? I think we may have talked about that a little bit, but maybe you want to comment just so we make sure I get this question answered from one of the attendees.
Sure. So typical measurement error is a very difficult thing to get at, right? It sort of depends on the constituent. And then again, in many cases, the wet chem, the primary method being used. Yep. In most cases, so you could expect, depending on, let's say if we're talking for an IV value, if your IV values were from, between 1 and 150, you could expect to be within, plus or minus 1, but actually better than that. Things like free fatty acids, again, depending on the range, you could certainly, depending on whether it's crude, whether it's more refined, you could be within 0.02 or 3%, depending on your full range. So again, it kind of depends on the wet method, though.
Yep. Yeah, I agree. Let's see. There was a question here. Follow-up says your protein analysis was that you showed in your presentation. Was this by Kjeldahl or the Dumas method? Chris?
I'm sorry. I didn't.
That's okay. So that in your presentation you showed a protein analysis. Was that by Kjeldahl or was that by the Dumas technique?
So I don't know what the wet chemistry was for that particular technique. It's not as important what technique is used. We're calibrating to the results that are obtained. So whatever technique you're using is, what we're going to use to calibrate to. And that's really the take home of this, is there's not a preferred or a recommended technique that we give. It's use the one that provides you with the best results, and we'll calibrate to that.
Great. All right, I'm going to try to move back to some other panelists. You have a few more questions, so give me just a little bit of time. I'm going to circle back up and see if we have any other questions here. May have one more for Ernesto here. It says on EPA plus DHA above 50%, but what would be the upper limit? I think they had a question about that ratio.
Yeah, that's one of the bigger issues with concentrating these omega-3s by molecular distillation. The process sort of hits the wall, if you will, by molecular distillation. Basically, to concentrate these omega-3s through short path distillation, you have to use high vacuums and very short residence times and very high temperatures, and also do several passes through the unit to be able to concentrate to higher than 50%. And some processes can go up to 55%. And then from that, it goes on to either urea crystallization or preparatory chromatography, absorptive methods to concentrate to the 85% that these pharmaceuticals, that are prescribed. Actually, these omega-3 ethyl esters are prescribed, as medication by doctors to prevent cardiovascular events. So the advantage of this system of having multi-stage internal systems is that you can mimic several passes through a molecular distillation unit, and it allows you to go to 55, 60%. And this is, we just have started doing this, by the way. The applications, just started. So we are, as we speak, doing further tests to see how far we can get by not mimicking, actually. They are actual internal stages in the unit that, for example, with a conventional short path distillation, you have a stage of one, basically. It's one pass, one stage, it goes right through. With this system, with this artisan system, you have multi-stages internally with these distribution plates going through, and you can make them as long as you want, as long as necessary to achieve your concentration. So just to answer the question real quick, we don't know yet how far we can go in concentration. Right now, it's way above 55%, and this is information that will come out very soon. And for our next meeting, we will hopefully have a more complete report on this. But it goes much higher than the conventional molecular distillation units as far as concentrating EPA and DHA in these short path systems.
I have one other, it's okay. I have one other follow-up question for you here.
Sure.
And that is, it talks about 3 MCPD esters. They are not very volatile. It asks, is your technology stripping them out of the oil, or is something else happening?
They're stripping them out. We are able to have, again, we have the capability of having very high vacuums. Since we are using an internal condenser, we don't have these pressure drops that you usually have with a deodorizer, for example, or a physical refining system. So by having these internal condenser capabilities, our pressure drop is minimal. So we are able to have very high vacuums and being able to distill them off. So just want to be clear about that. And also real quick, we can also adjust temperatures. These systems are jacketed, or you have the option of jacketing them. So you can adjust internal temperature as well. Okay. So you have, again, the option of having a feed temperature and not having a internal jacketed system, or you can have an internal jacketed system and being able to adjust the temperature and go as high or as low as you want. So it's very, very, very innovative in that sense, very flexible.
That's good. All right. Thank you.
You're welcome.
All right. I want to move on down. I had another couple of questions come in for you, Christopher. It says, can you determine solvent such as ethanol or hexane extracted oil ratio in line?
Yes, you should be able to. With some of the solvent extractions, you shouldn't be able. You can look at. I would assume this would be for something like a flakes application or something in that. Yes, in fact, we are working on that in a variety of applications currently. projects that we're doing for them.
Okay. I think that there's a few questions here about calibration, and maybe we can run through those real quickly. It says, does an NIR device need setting up on site by an expert, or does it, and I think this is a separate question, does it come fully calibrated from the factory?
So depending on the, for an inline instrument, there would of course be installation and setup. Depending on the application, Bruker does have a catalog of calibrations for a variety of constituents and a variety of product types. What is often required is if not always a full calibration development, but at the very least, we'll usually need to take some samples, excuse me, and sort of integrate them into a model. So, apologies. So basically, if you, seed, what we call seeding a calibration, if it's already developed, that will kind of allow it to learn for any little differences that might be that might be different from the product at a given site versus a master calibration that was developed. And that's just part of sort of a model maintenance that is often done. But one of the things about the transferability of the calibrations is a lot of times, if you can develop a calibration at a site that has the resources to do it, the lab resources, you can send those calibrations out to other sites without having to do the setup and the work. You can just put them in and begin using them because of the ability to transfer calibrations between spectrometers.
All right. There's one other question about calibration. It says, which compound is used to calibrate the fat content measurements?
I'm not sure I understand when they say which compound is used to.
Yeah, I guess the question might be maybe better answered is, fats there are a range of individual molecules that make up fat content, molecular weight distribution. And so would you use that, or maybe you might use something like a supercritical fluid extraction method as a primary method versus trying to have a single component method for calibration?
Right. So again, it's not as critical what primary method you use. Typically, when you are looking at an NIR spectrum, you're going to have regions that calibration is going to sort of key on when it develops the model. So the software is going to looking for changes in spectral features, shifts, absorbance changes, and it's correlating those to the wet chemistry changes that are input based on that primary method. And what you'll typically see is where the region of the calibration will choose for fat will be the CH stretches that are present in the spectra themselves. So you'll see that it tends to choose the regions where that variation is most pronounced relative to the wet chemistry. And again, that's just a natural result. That's the physics of spectroscopy and where the fat content presents spectroscopically.
Yep, I think there's one last question here for you, and it says, can you sense in line the concentration of extracted oil in the solvent, or in other words, determine the oil solvent ratio?
Sure. So, I mean, that, when you can determine either a constituent or multiple constituents, you can always mathematically arrive and at a ratio, or you can perform a calculation and actually have your results presented or sent back as a ratioed or a calculated value.
Yep. Okay, good. Thank you very much. So I just want to remind our audience, if you have questions for our panelists, please type them in. We want to make sure that if you have questions, that they get addressed and answered by our panelists. We have a few more minutes in the question and answer session here, and I think we've run through most of our questions at this point, but I would really appreciate it if you have some additional questions. Please type them in at this time so that we can have our panelists answer those questions, or at least try to address the questions that you might have on any of the presentations. I'm going to look here, see if any more questions are coming in. And at this particular point, I don't see any new questions. So I guess on the behalf of the AOCS, Amy, at this point, I don't see any additional questions, but on behalf of AOCS, I want to thank each of our speakers today for preparing a good presentation for our audience. Certainly, we've had a lot of questions. I think there's a lot of interest in the content that you've delivered today. So on behalf of AOCS, thank you for participating and sharing with us the results of your work and your findings. And again, audience, thank you for listening in to us. If there are no more questions at this time, I think, Amy, we might actually end the session a little bit early, unless there's some more questions coming in that I don't see here.
No new questions. So thank you, everybody. I think you can close us out, Larry.
All right. Well, listen, thank you very much for your participation. Hope everyone has a great day. And again, please take a look at the AOCS schedule. There are additional sessions of interest. So many of our speakers here have additional presentations, and I'm sure they'd love to have you participating in those panel discussions as well. So again, thank you very much for joining us today, and I hope everyone has a great day. And thanks for joining and supporting our industry through AOCS.